Welcome back. So we just got done with our chemistry analysis of our soil, and now we're moving into the physical analysis or physical properties of the soil. And so we're going to do a couple of tests. One of them is looking at pore space and size of the soil types, and then the other one is the water holding capacity and the leaching time of the soils. All right, so we're going to start off with our sand. Basically, we did 2 tablespoons of the sand, and we put it in a mortar with a pestle, and we grounded it up. And sand is typically bigger in particle space. It's very crystal-like. So typically, sand would be able to have a faster leaching time because of the pore space. And so a lot of the water and other types of chemicals that might go in to the sand would leach out faster. And with that, it would have a small water holding capacity or water retaining. Thus, it will not hold a high amount of water. So certain plants will do fine in this type of environment, like succulents, but other plants will not do great, especially that need a high amount of water quality. So Sanhita will be calculating and measuring how much water was retained in the sand right now. We basically put 30 milliliters of water in each of the substrates and let it settle out for a specific time. And then we are going to take the remaining water out to see how much water difference is left in the sand. Right, so she'll be directing and looking at this right now of the measurement.
So that is 16
Okay.
out of the 30.
Yep. So 16 out of the 30 was able to leach out, thus sand only retained 14 milliliters of water. So this water holding capacity was only 14 milliliters. So that's not a huge amount, that it did retain some of that. Yeah, half of it. And so the next one we're going to do is our clay, right? So our clay is actually very, very small particle size, and oftentimes we use clay to build pots and pottery, and oftentimes clay can retain a lot of water, right, or hold it in, right? So again, we did the same procedure of looking at the clay particle size, putting 2 tablespoons, using a mortar and pestle to, kind of keep it uniformed. And again, we put this in our funnel with our cotton ball. And again, we put 30 milliliters of water to these 2 tablespoons of the clay. And then we put 30 milliliters of water to filter out from the clay. And we looked again at how fast water was able to come out and leach from the clay and how much water was retained. And typically, clay takes a slow, long time to leach out, right? So it doesn't have a fast leaching time like the soil. It's actually on the opposite end of the spectrum. And with that, clay is also the opposite end of the soil by retaining a huge amount of water. So we're going to, again, look at how much water is retained in the clay by pouring it out into our graduated cylinder and measure how much water was coming out and looking at how much water was retained. You're doing great.
Most of the water's up there. Ooh, nothing.
Okay, so we have nothing, right? So from that, we had all the water was retained in the clay. That means 30 milliliters of water was retained in the clay, and we had no water leaching out, right? So we did a good job really mortar and pestling that clay, right? And our last type of soil is our topsoil, and topsoil is so important. That's where most of our plants get the nutrients from. And with our topsoil, we want a lot of organic matter. We want some particles of minerals. It's a living ecosystem in its own right. It has worms and beetles and bacteria and fungus, and our roots are living in there. And so again, we meshed around our topsoil. It should be kind of in between the clay and the sand. Again, a wide ride of our agricultural production depends on our topsoil. And we're going to, again, do the same procedure. We did 2 tablespoons in our mortar and pestle, and then we put it in the funnel system where we put water to basically percolate or infiltrate out. And we recorded the time, which should be in between the sand and clay for the leaching time, and then we measured how much water was retained in our topsoil. So again, Sanhita is going to measure out how much water was retained in our topsoil. All right.
Yeah. So that is, I'd say 3 over here, so 27.
Okay, so 3 milliliters of water was able to leach out, and our soil basically held or retained 27 milliliters of water, which is great for the plants to absorb and utilize for its growth. And there you have it. We did the chemistry and physical analysis of soil.